So the two that we had left, number 7 and number 8, what do we call these types of functions? They have a name. It starts with P. I'm going to stand here until somebody says it. Piecewise. Thank you. Jason looked back in his notes. Guess what? That's why y'all have those. Okay? Piecewise functions. It has pieces. It's not just one single function. It has pieces of multiple functions. So we've dealt with these before. Let's review it again. This time our piecewise functions involve some absolute value functions that we were just graphing. So let's see if we can take a slightly different approach here to help us out. Look at the x value where it changes. X is less than 4, x is greater than or equal to 4. So let's try this. Find x equals 4 on your graph. 1, 2, 3, 4. We are right here. Okay, what I'm going to do is I'm going to put a dashed line right here at x equals 4. So that I know when I look at this, the left side, x is less than 4, and we're going to write this above it too. We're going to say, well, this side is x is less than 4. So it should look like the function negative 2x plus 1. Hopefully we know how to graph negative 2x plus 1. What's the y-intercept? Which part of that equation is the y-intercept? Okay. mx plus b, right? mx plus b. So b is the y-intercept. So what is our y-intercept? 0, 1. Okay, so y-intercept is 1. Our slope is negative 2. Okay, so we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Now I'm on the line that I just drew. So do I put an open circle or a closed point? Does my inequality have the equal to or not? For the first piece, does the inequality does not, so we put an open circle right down here. Okay, now that's where my line is, so it doesn't look very open, so I'm going to fix that right here. Okay, open circle right here. Now, I could have most definitely used my calculator to graph this, but I just wanted to review the fact that we should know how to graph a line if we have the equation of the line using the slope and the y-intercept. So this is what the left side of my function looks like. The right side, when x is greater than or equal to 4, this is the right side, I use that absolute value function. I use the absolute value function. So I start at 4. X equals 4. So I'm going to plug 4 into the equation. 4 minus 3 is 1. The absolute value of 1 is 1. So at 4, 1, I have a point. And then I'm going to plug in 5. 5 minus 3 is 2. Absolute value of 2 is 2. I'm going to plug in 6. 6 minus 3 is 3. Absolute value of 3 is 3. I'm going to plug in 7. 7 minus 3 is 4. Plug in 8. 8 minus 3 is 5. So that's what the right side of this function looks like. So even though that right piece, that second piece, is the absolute value function, it doesn't really look like it because we don't include the vertex. Where's our vertex? Based on what we learned yesterday, where is our vertex? What x value? Where's our vertex? What x value? How do we find that? What did we learn yesterday? How do we find the x value of the vertex? Flip your paper over. How do you find the x value of the vertex? Okay, it is the turning point, but how do we find it? It's step 1 in the list of steps. How do we find it? We set what's inside the absolute value equal to 0. So where is our vertex? At positive 3. Okay, at positive 3 is the vertex. Well, this piece does not apply until we get to 4. So we don't include the vertex here in this piecewise function. Okay, so even though it's the absolute value function, we really don't see that in the graph because of where it picks up. All right, so domain. All real numbers, okay? We hit everything because this one leads up to 4, this one picks up at 4, so we do hit all the values, all the x values. How about our range? Do we see a maximum or do we see a minimum here? We see a minimum, so our y values are greater than or equal to, nope, not equal to, because that's an open circle down there. Y is greater than, okay, because this is an open circle, so we don't actually equal this number, but what is this number? 2, 4, 6, negative 7. Okay, negative 7. We get really close to negative 7, but we don't actually equal negative 7. Okay, so we can get as close as we possibly can, negative 6.99999. Okay, but we won't actually equal negative 7. Okay, let's do one really quickly that has 3 pieces. Okay, fun, right? So, let's look at where we change at negative 3. Okay, so I'm going to put my vertical dotted line there at negative 3. This is x is less than or equal to negative 3. I'm going to go ahead and mark off my other spots too. At 2, it changes again over here at positive 2. So we've got between 3 and 2, and then we've got greater than or equal to 2. So our first piece there, when x is less than or equal to negative 3, our first piece is the absolute value of 2x minus 4. So let's see here. If I'm just using my graph here, how far does my graph go? That's negative 3, negative 4, negative 5, 6, 7, 8. Okay? So I'm just going to start on the very left side of my graph here. I'm going to plug in negative 8. Okay, so when we plug in negative 8, 2 times negative 8 is negative 16. Absolute value of negative 16 is positive 16. 16 minus 4 is 12. Well, 12 is off of our grid here, so I can't plot that one. Let's see if we can plot 7. Okay, or negative 7. 2 times negative 7 is negative 14. Absolute value of negative 14 is positive 14. 14 minus 4 is 10. Still can't graph it because my thing only goes to 8. Okay, let's try 6. 2 times negative 6, negative 12. Absolute value of negative 12, positive 12. 12 minus 4, 8. Finally, we can plot a point. Okay, negative 6, positive 8. Okay, let's plug in negative 5. 2 times negative 5 is negative 10. Absolute value of negative 10 is positive 10. 10 minus 4, 6. So negative 5, 6. I could get these from a table, okay? I can get these from the table in the calculator. I'm just showing you how to just use what's in front of you. Where are we at? Negative 4. 2 times negative 4, negative 8. Absolute value of negative 8, positive 8. 8 minus 4 is 4. And then negative 3, we can use negative 3 because it's x is less than or equal to negative 3. So 2 times negative 3 is negative 6. Absolute value of negative 6 is positive 6. 6 minus 4 is 2. So there is that piece of our graph. It stops there at negative 3, positive 2. Okay, that's as far as it goes. Now, it gets an arrow over there on the left side because it keeps going on the left side. Okay? Between negative 3 and positive 2, our function is always equal to negative 5. So let's find negative 5 down here. 1, 2, 3, 4, 5. Okay? And we're going to put open circles on both ends of this. Okay, put open circles on both ends of that because this one doesn't have any equal to's on either side of the inequality. So both sides of that get the open circle. Okay, and then finally our last piece, we start at 2. X is greater than or equal to 2, so plug in 2. 2 minus 2 is 0. So 2, 0. Plug in 3. 3 minus 2 is 1. Plug in 4. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. 8 minus 2 is 6. Here's the other side of our function. Okay, notice nothing overlaps, nothing crosses. That's it. Okay, so how about our domain? All real numbers. We start over here on the left. We've got graph, we've got graph, we've got graph. We jump down here, we've got graph, graph, graph. We jump back up here, we've got graph for the rest of it. All real numbers. Now, the range is a little weird. Okay, let's start at the bottom. We don't have any y values, we don't have any y values, we don't have any y values. Then all of a sudden, at -5, we got y values. Okay, but that's the only place until we come up here and we hit, there's a gap right here. We don't hit any of the y values right here between -5 and 0. Okay, then all of a sudden at 0, then we're going to continue up from there. Okay, so this one has a weird range. It equals -5, and then everything that is 0 and bigger. So that was a little weird, but that's how you would write that. Okay, so I want you to